Assalamualaikum. My name is Muhammad Sega Sufia Purnama. I will represent my friend Sarah Aisha and Afi Mantari to explain our research with title Modification of Movable Louver for Indoor Lighting Distribution. Our background is the movement of the sun makes shading tend to be less effective. Shading should respond adaptively to the movement of the sun, but shade will reduce the intensity of light in a room. Modifications are needed to the movable shade so it has double function. In addition to protect from sunlight, it can also be a light shelf to reflect light into the room so that the light intensity can be maintained. The purpose of this research is to modify and test the performance of the set to make it more optimal. Our research methodology is first, this research starts by selecting the shape of the set that is commonly used in building, then making a room model in Dialog software, testing the performance of the static Louver, and then enhancing the performance with make it rotate. Testing again the performance for a second time, and from the result, we modify the element by understanding how light can be distributed further into the room. Testing again the performance for a third time, and then finally analyze and make a conclusion. This is the dialog software setting we use in our research. The reference sky type is Sky. We use location in Jakarta, and we use time from 12 a.m. until 4 p.m. Next, this is the model, the room model. The aspect observed is the intensity of light entering the room and light distribution. Model of the room was created with dimension of 5 meters in length, 5 meters in width, and 3 meters in height. A clear glass window with 4 meters in length and 2.5 meters in height was used. The window is located on the west side of the room. So the side we test the performance is in west side. Next, this is the result and analysis. First, this is the room model with horizontal static Louver. From the recent research, there is many proof that static Louver is more optimal for high latitude of sunlight. So in this research, the starting point is we use static Louver, and the result of the simulation indicate that the light distribution reached the backside with a high intensity value. The high value is disadvantageous for the activity. It is therefore necessary that the motion of the Louver follow the angle of the sun. From the picture, we can see this is at 12 a.m., 1 p.m., 2 p.m., 3 p.m., and then 4 p.m. We see there is a line start from 1 p.m. 1 p.m. until 4 p.m. The line shows that the direct sunlight go through the room. Even if we use the static Louver, horizontal static Louver, the direct sunlight still can penetrate. So the intensity and the light distribution in the room is not suitable for activity like reading or maybe writing. So this condition must be uh, modified with we rotate the static louver and we rotate it at the back point like this. Yes, this is the static louver and this is a movable louver. Yeah, this is the movable louver. We make it rotate from start 12 a.m. Rotate slowly until 4 p.m. Yeah, the degree of movement, degree of rotation is follow the sunlight latitude. We can see from the picture, 5 picture below, there is a change from 12 a.m., 1 p.m. until 4 p.m. There is a change of the rotation from the slat horizontal. And the result is indicated that the reduction in light intensity begin at 1 p.m. and persists until 4 p.m. From 1 p.m. to 2 p.m., the average light intensity across the entire space is 100 lux, with some localized area near the window reaching 300 lux. At 3 p.m. to 4 p.m., a decrease occurs in half of the space, with the value below 100 lux. This value is indicated of a reduction in light intensity due to the decrease in sunlight rays, necessitating modification to shading. So, from the modification from static to rotate the slat horizontal, there is a change in lighting distribution, but the decrease is less than standard that we use for suitable activity, maybe like reading or writing or maybe studying. So we have to modify it again with add light self slat in the back of the lower slat. This light self we put 130 degree and from 1 p.m. to 4 p.m. their movement, movement from this condition to this condition, and it affect and make sunlight get reflection from light self slat and sunlight get blocked from the lower slat because its rotation and modification of the slat from 12 a.m. until 4 p.m. The result is it can be observed that the modified louver show a lower lux value than the movable louver. At 1 p.m. to 2 p.m., the modified louver reduced the incoming light intensity but remained above the lighting standard. At 3 p.m. to 4 p.m., the lux value of the modified louver showed an increase. The movement of the light self stats allow more light to enter the room, resulting in higher lux value of 165 lux compared to the movable louver, which has a value of only 170 lux. So, the conclusion is, in terms of light intensity distribution, it is observed that over half of the area within this room is illuminated illuminated to a sufficient level for activity or above the minimum lighting standard. This indicated that the modified louver exhibit better performance in comparison to the movable louver. Further research is required to certain the optimal form of other material or types of movement in order to get a better relative facet design. Okay, thank you for attention. Assalamualaikum.